Hi everyone. So today we are going to talk about sampling. So in the last lecture, we learned more about regression and how to re-express data. So textbook talks a little bit about randomness. It's a quite an interesting topic, but I'm going to skip the topic. Rather, I'm recommending you watching these videos from Vsauce and Veritasium. Okay, so today we are going to talk about sampling. The idea is we have to examine a part of the whole, because what we really want to know is about population, that is the entire group of individuals, but we cannot really see the population itself. So we have to just stick with the smaller sample, a smaller group of individuals that we call sample, that is selected from a population. But it is really difficult to ensure the sample represents the population well. There is a possibility that the sample over or underrepresents some characteristics of the population, and this is a really good example. There was a literary digest poll that is really famous poll that done by this journal. They conducted a poll to predict who is going to become president. Many problems in this poll. One of them is they sampled response using phone calls when telephone was a luxury. So they predicted presidential candidate from right wing becomes a president, but it was not. There was a Lyndon versus Roosevelt competition, and Roosevelt became president, different from their prediction. If we are using biased samples, your prediction will be wrong. So we want to really get the right sample, but how to do that? The idea is randomize. So to make sure the sampling is not biased. And sample size matters. The important thing is not the fraction of the population, just we need good size of samples that can represent the population well. So if the population is really large, we don't need, like, for example, 10% of the population, but for example more than 100 or 1000 samples. That would be good representation of the population. And there is a special form of sampling, that is census, that examines the entire population, but it is really difficult to complete this census and gonna be more noise. Given that this is gonna take really long, the subjects are not gonna stand still. They will change. So census is a really hard challenge. So there are population parameters, and that is parameters to model for a population. And there is a sample statistics, that is summaries of sample data to estimate the population parameters. We are using these symbols for sample statistics, Y bar, S, R, B, and P hat. And for the population parameters, we usually use Greeks: mu, sigma, rho, beta, and P. So there are multiple sampling methods. The first one is simple random sampling, where each person has an equal chance of being selected. And there is a stratified random sampling. This is a very popular method. So we first define strata. The population is first divided into homogeneous groups. Like, for example, male and female, or different groups of age. Then do simple random sampling within each stratum before the results are combined. So for example, if my population is the campus students, the students are comprised of 60% men and 40% women, and then we can randomly sample 60 men and 40 women for 100 subjects. So 100 subjects is a sample, but we can keep the same proportion of the each stratum similar to the population. And there is a cluster sampling, that is splitting the population into representative clusters, and then select one or a few clusters at random and do census. What is different from stratified sampling? So clusters can be heterogeneous. So it's like a cake has multiple layers. Stratified sampling is getting one layer, each layer, that is strata, and then you can sample within the stratum. But the cluster sampling is getting piece of cake that has all the layers. And there's multi-stage samples that combines several sampling methods, and systematic samples, that is select samples systematically. Like, for example, survey every 10th person on the list. Common mistakes in sampling. The first one is sample volunteers. And volunteers have their own characteristics. So that calls voluntary response bias, and they could be different from non-volunteers. And second mistake is sample conveniently. Just get the sample that you can get easily, and they may not be representative of the population. And third one is use the bad sampling frame. So incomplete sampling frame introduce biases. And under coverage, so some portion of the population might not be sampled at all. And non-response bias, so those who don't respond may differ from those who do. And there is a response bias as well. So survey design can influence the response. So that is response bias. So there was a really interesting example when I prepared this lecture first, and this tweeter came out. Kairos, I think he is a graduate student somewhere, and he presented this poster, and it shows that the volunteers for pain research could be quite different from those who do not. So he concluded that the volunteers in pain research might represent an especially resilient subset of individuals and who actively seek out novel stimuli. So yeah, this kind of research could alert many pain researchers that maybe our volunteers, the subjects might be quite different from other people. So we need to be careful about generalization of our findings. Okay, that's it for today. And don't forget to do quiz. The link is below in the note. Thanks, and see you in the class. Bye.